about rational exponents, but we need to know what the word rational means. So what I want you to do is look inside the word rational, and you'll see the word ratio. And maybe you remember that the word ratio means a fraction. So a rational exponent is a fractional, which is not a real word, exponent. In other words, an exponent that looks like a fraction, like x to the 1/2 or x to the 5/7. We're going to talk about these rational exponents and what they mean. Because when you think about what an exponent means, as far as you can remember it, an exponent means repeated multiplication. Like x to the third means x times x times x. What does it mean to multiply half of a time? So in order to answer that, what we're going to do is take a look at a different kind of number line. We'll give it a name later in the year. You don't worry about that now. That other number line looks like this. 1, 4, 16, 64, 256. Notice how I'm not counting. It looks like I'm not counting by an even amount. But I am. It's just that I'm not counting by addition like you're used to seeing on a number line. Instead, I'm counting by multiplication. I keep multiplying by 4. So the first step is 4 to the 0 power, then 4 to the first, then 4 to the second, 4 to the third, 4 to the fourth. So each time I take a step here, I am multiplying by 4. What I want you to notice is that it's not just, it happens to be that I broke it up by 4s there, but it doesn't have to be 4s. Like if I think about this step, I'm multiplying by 16. If I take that same size step over again, I'd be multiplying by 16 again. So the step that we're looking at are the ones where I'm multiplying by 4 every time, times 4, times 4, times 4, but it could be times 16 also. Okay. So my question is, what would be, so if we look at 4 to the 0, 4 to the first, halfway in between 4 to the 0 and 4 to the first would have to be 4 to the 1/2. All right, because 1/2 is halfway in between 0 and 1. So my question is, what is this number in here? Halfway in between 1 and 4, but not halfway when you're adding, right? Not the average of 1 and 4, but halfway when you're multiplying. In other words, what would you have to multiply by that if you were to multiply it by again, you would get to 4? That's what 4 to the 1/2 really means. The number that if you were to multiply it by twice, you would get to 4 to the first. Or the number that is halfway to 4 by multiplication. Well, we have a name for that. The number that if you were to multiply twice would get to 4, that is another way of saying the square root of 4. So that's what this number is here, the square root of 4. Makes sense. If you multiply by 2 and then multiply by 2 again, you get to 4. So in that sense, by multiplication, 2 is halfway to 4. So what you've always thought of as a square root can also be thought of as a rational exponent. And that's the key, that a rational exponent is the same thing as a radical. If you say it the other way, the denominator of that exponent, so whatever this is the index of the radical. They go together. X to the 1/2 would be the square root of x. X to the 1/3 is the cube root of x. X to the 1/4 is the fourth root of x. And the numerator just sticks around. Notice how that 2 is just still here. That's it. That's all you have to do to turn a rational exponent into a radical. Is take the index, or take the denominator, write it as the index. So sometimes this is really useful for radicals. The 6th root of x to the 3rd, well, clearly I can't take I can't multiply anything 6 times to get to x to the 3rd. But if I think of this as a rational exponent, where I take that index and I write it as the denominator of the exponent, that becomes x to the 3/6. When I think about it that way, I can then reduce the fraction to make that x to the 1/2. So I can write it as a much simpler looking radical. Instead of the sixth root of x to the third, I can think of it as just the square root of x. So that's one way that these rational exponents are useful. Sometimes it goes the other way. Sometimes it's actually, you can take a rational exponent and think of it as a radical. So 27 to the 4/3, this 3 is the same thing as the index of the radical, so the cube root of 27 to the 4th. Now, I don't want to know what 27 to the 4th is. But the nice thing about radicals and exponents is that they all fit in the same order of operations, which means I can reorder them as much as I want. And I can think of this as the cube root of 27 to the 4th, which means instead of having to do 27 to the 4th, which is a ridiculously oversized number, I can instead think about the cube root of 27, which is a nice manageable 3 raised to the 4th power. And that I can do quickly in my head. 3 times 3 times 3 times 3. Or 3, 9, 27, 81. One thing to keep in mind, last little bit here, is that old rules of exponents still apply even to rational exponents. So x to the 1/2 times x to the 2/3. What I'm doing here is we would call this the product of two powers, or multiplying two powers together. We know that we're supposed to add the exponents. So x to the 1/2 times x to the 2/3 would be x to the 1/2 plus 2/3. Adding those fractions, I can do it on the side here just to show you. 1/2 plus 2/3. We'll do much more of this later in the year, but remember from earlier math classes you've learned you need to make a common denominator. So 1/2 is the same as 3/6, and 2/3 is the same as 4/6. So put them together and you make 7/6. So this is the same thing as x to the 7/6, which is the sixth root of x to the 7th. Or if you, to simplify that, we can do 7 divided by 6. We can actually, that's 1 with a remainder of 1. So x times the sixth root of x. That is what you get if you try to multiply the square root of x times the cube root of x squared. Turning them into exponents would allow us to use the properties of exponents that we know. Similarly, x to the 1/3 squared. This example might be a little bit too simple, but x to the 1/3 squared, we learned that when you have a power raised to a power, you can just multiply the exponents. So x to the 1/3 to the second is the same thing as x to the 1/3 times 2, which is 2/3.